Okay. Guys, for K method, like I said in the video, if you are getting any question like this one, right? And this is very similar to the example that I did in the stage lesson. If you were to actually write this bracket as the bracket multiplied by something which multiplied out, you would get an x to the 4. And as soon as you're getting an x to the 4, you need to start thinking, oh gosh, we don't know how to work with that, so let's look for something that will make it easier. So then you need to look for an expression that is repeating. Okay, now like I also said yesterday, it's not always going to be in brackets, and you would have seen that in the questions as well. It's not always a bracket that you pick. In the first case, it was. So then we introduce another variable. Usually I was okay using what, and we say that this repeated expression is equal to that other variable. Okay, so if this bracket, and it helps, guys, if you actually underline that thing, because then whatever you've underlined is now going to be k, right? It makes it easier. So if you underline that and you underline that, it's going to be the underlined bit squared, so k squared, minus 2 times the underlined part, so minus 2 times k, minus 8 equals 0. Okay, and guys, for that you get them off. Then you can solve this now whichever way you want. If you wanted to factorize, and you'll see a bit further down, I did actually start this factorizing. Just to remind you that you can do that if you are able to factorize a trinomial, all right? But you can also always just use the quadratic formula. It's completely up to you, whichever method you prefer. So if we use the quadratic formula here, a is 1, b is -2, and c is -8. Right, so you would sub in those values and get the true answer for k. Now guys, we need to remember that k is actually the underlined section. So that means that these two values that we're getting for k, those two values are actually equal to the underlined bit, which is x squared plus 3x. So once you've found your answer for k, you then replace k again with the x squared plus 3x. So here we have k equals 4, but k is actually the repeated expression, x squared plus 3. So you're just taking that equation and you're putting back the actual x squared plus 3x equals to 4. On the other side, you put it back, instead of k, what was k again? X squared plus 3x equals -3. Okay, then from there, you can see here I factorized, because I was rushing. I didn't want to take all that time to write out the formula, but it's fine if you do the formula, okay? So we'll get the correct answers every single time. So please, if that's what you want to do, that's perfectly fine. First, we do need to move this 4 over so we can get it in standard form, right? So then a is 1, b is 3, and c is -4. Then if you plug it into the quadratic formula, you'll get those two x values, -4 and +1. And then from the other one, you have to do the same thing. To get it in standard form, you need to move the -2 over, it will become +2. Then here, a is 1, 3, b is 3, and c is 2. Okay, so that's all. You didn't have to factorize, you can just use the formula, and then we'll get the same answer. Okay, and that's basically what you have to do every time, right? You look for the repeated expression, you replace it with k, solve for k, then put the repeated expression back equal to those values. Right. So we're looking at the second one. This one is now one that we didn't do an example on, so it's fine if you struggle with this one. There's also an equation with fractions, so it was a bit more complicated. So here we have this repeated expression, y squared plus 6y. So that we are going to make equal to k. So we're going to say let k be equal to y squared plus 6y. So we have the underlying expression is k minus 35 over that expression, so 35 over k equals 2. Right? Any questions on how I got to this line? I took the repeated expression, I made that equal to k. Then from there, we now have an equation with fractions, right? So equation with fractions. Then we have to times by the LCD. Right now, since there's only one denominator, there's only one fraction, and that denominator is k, that means that the LCD is k. So you can see that I multiplied every term by k. Alright, we just practiced before. So k times k is going to be k squared. Here, the k at the top and the k at the bottom are going to cancel out. And that is going to be 2 times k, which is 2k. Move that 2k over, and now here you could have figured out the formula to solve for k, and you would have gotten those two answers. Right? Which is perfectly fine. Remember that you have to show that line where you're putting in all the values into the formula to get them off. Okay, if you just go from the equation straight to the answer, you're going to lose them all. Okay, so you have to show the formula there. So now we're getting that k is 7, k is -5. So now k, remember, was y squared plus 6y. So that is equal to 7, or y squared plus 6y is equal to -1. Right. Move the 7 over. You can use it without the formula. You'll get those two answers. Here you move the -5 over. You can use it without a formula, and you will get those two answers. Right, are there any questions, guys, on these two? I'm not going to mark 3 and 4 now, because if you were unsure of how to do these, yesterday I want you to try those again, 3 and 4, if you weren't able to do it. If you were able to do them twice, okay, we'll mark those tomorrow. All right, so if you were able to do 3 and 4, you don't have to redo them. It's just if you were not sure of how to actually do these two, then you need to go and try 3 and 4 again. Okay, we are going to do a different type of equation today, though. So when you guys are ready, we will just start writing down that note. And the heading is surd equations, please. Surd equations. No. They'll say solve for x. Okay, surd equations. Right, surd, S-U-R-D equations, that's what we do now. Okay, now guys, I don't know if you know what a surd is. It's like a root, right? So like a square root or cube root, whatever. Those are called surds. So when I say surd equations, I'm using something line. I'm going to write solve for x. Examples. Like the square root of x plus 1 is equal to 5. Okay, so the x, the variable, the thing that we're trying to solve is in a surd. Right? Does that make sense? Yeah, the square root of x plus 1. Okay, so that is what makes it a surd equation. The variable is in the surd. So you can write that at the top. Variable in the surd, in the root. And as for these types of equations, we are again going to follow specific steps. Right, the first thing that you always want to do, and it is actually done in this case already, but the first thing that you want to do is to make sure that the surd is isolated. The surd is on its own on the one side. All right, so that is always the first step. Now right here, isolate the surd. So it's different from the quadratic equations that we've done, right? With the quadratic equations, we always try and get everything on one side and have it equal to 0 on the other side. We're not going to do that in this case, right? We're going to make sure that our surd is on its own and everything else is on the other side. Right, now guys, remember when we're solving an equation, we want to get rid of everything except for the x, right? We want to just have the x on its own. So the first thing that we're going to try and get rid of here is actually this square root. Right, now when we're solving an equation, when we move things over the equal sign to the other side, we do the opposite operation. Now what do you guys think? What is the opposite operation of square rooting something? Squaring. Okay, so that's what we're going to do, guys. In order to get rid of the square root, in order to cancel it out, we're going to have to square the whole thing, right? Because what is the square root of 2 squared? Do you guys remember that? I think you did that in grade 8. The square root and a square will cancel each other out, right? Do you remember that? So this answer is actually just 2. Okay, so we are using that concept. The fact that a square root and a square will cancel each other out. So we are going to square the surd, but guys, this is an equation. Whatever I do on the one side, I have to also do on the other side. So if I square the surd to get rid of it, then I have to square the 5 as well. Okay, so that is going to be the next step. Square both sides. Okay, so you can just do it in the same line if you want. All right, you can just show there, maybe using a different color pen or maybe a pencil. You're going to just square both sides. So that square is going to cancel out the square root. So what's going to be left on the left-hand side? If the square root goes away, just x plus 1. And on the other side, what is 5 squared? 5. And now we can just solve for x quite easily, right? What's the opposite of adding 1? Minusing 1. So 25 minus 1 is 24. Okay, now guys, yes.
So it was 5 plus x with the x.
Yeah, so we'll do an example, then you would have to square both terms. So then it's going to be a binomial square. Yes. Okay, we'll do an example like that now. Now guys, for any equation, remember, it's good. You don't always have to do it, but it is good just to check whether your answer actually works. Right, so if x is 24, you don't usually get such big numbers for it. Okay? That's a bit unusual. So if you're uncertain, you can just put it back there. So in the circle, we're going to have 24 plus 1, which is 25, right? What's the square root of 25? It is 5. Okay, so if x is 24, if I actually take that value and put it back into my original equation, it does work. Right, it does equal the square root of 24 plus 1 is equal to 5. Okay, so it does work. Right, next example. If we have 1 plus the square root of x plus 1 equal to x. But before we carry on with this example, let's just quickly add the third step here. We isolated the surd, it was already given like that. Then we squared both sides and then we just solve for x from there. Okay, so that will be the next step. So for x, or whatever the variable is, right? Okay, so now do we notice that the surd is not isolated? The surd is not on its own. There's a 1 plus in front of that surd. Okay, so we're going to have to move that 1 plus over to the other side. It's going to turn into a negative 1. Okay, so I'm going to have the square root of x plus 1 on this side equal to x minus 1. Okay, the surd has been isolated. First step is done. That's a mark. Right? Just from moving that 1 over, you'll get 1 more. Now we need to square both sides. So we're going to put a bracket around the whole left-hand side, square it, and around the whole right-hand side. So now we know that a square root and a square will cancel each other out. So I'm going to have x plus 1 here, just like in the previous example. But now, guys, we have two terms. X minus 1 squared. So it's basically a bracket that's being multiplied by itself, right? X minus 1 times x minus 1. You cannot just say the first term squared and the last term squared. Okay, you have to do it like that. It's a bracket that's being squared, a binomial squared. Okay, so we have x plus 1 still on this side. We need to FOIL these brackets out. X times x is x squared. X times negative 1 is negative x. Those are the alters, right? Let's do the inners. Negative 1 times x again is negative x. And negative 1 times negative 1 is positive 1. What type of equation is this now, guys? Quadratic, okay? Do we see that x squared? Let's circle that. So that now is going to influence the way that we go forward. This is a quadratic equation, meaning we need to get everything on the one side and make it equal to 0. Okay, we can actually move stuff to the right, okay? I have been moving stuff to the left all the time, but we have an x squared here. So let's keep this x squared here. Let's move this x and this plus 1 to that side. Is that fine with you guys? So we have our 0 on the left. You don't have to do it like that. You can do all your stuff to the left if you want. It's fine. We'll get the same answer. Okay, so we have our x squared. Let's quickly see what's going to happen with these x terms. I currently have negative x minus x. This is negative 2x, right? That's what I have at the moment. Now this positive x, when I move it, is going to become another negative x. So what is negative 2x minus x? It's 3x, good. Okay, I have a plus 1, and when I move this plus 1, it's going to become minus 1. So what's 1 minus 1? 0. Okay? And I'm going to show you a trick. What you can do, if you don't like having your stuff on the right-hand side like this, you can just swap the two sides. You can try to like that. Just, oops, not allowed to do that. Okay, do you know that? You don't have to move it, make it negative, move it. You can actually take the equation as it is and just swap the two sides around. Okay, because if you want them to move, and this is going to seem silly now, so please don't do this, but if you wanted to move that x squared, you would say negative x squared, right? If you wanted to move it. And then if you wanted to move this minus 3x, you would say plus 3x. And then that is equal to 0. And then do you guys remember a while ago I showed you that you can take out the negative 1 if you want to change all the signs. Right? Again, it's silly, so don't do it. I'm just showing you that you'll get the same answer. Right? They might have referred to this last year as dividing through by negative 1. We've heard that terminology before. You have a minus in front of your x squared, the teachers often say divided by negative 1. So you're actually taking out negative 1 as a common factor, and then you will say 0 divided by negative 1, which is what? What's 0 divided by anything? So 0, okay? So that negative 1 will actually just go away. So you'll be left with x squared minus 3x equal to 0, which is this, right? So you can bypass all of these steps, guys. If you want your equation to be the other way around, just swap it. Okay, but keep all your signs the same on both sides. Just swap it like that. Okay. Now from here, of course, you can use the quadratic formula, but let's just practice that factorizing. It might save you some time, all right? Because this is quite an easy factorizing to do. What can I do here if I'm looking at factorizing this? It's not a trinomial, right? It's just two terms. So we see that there's an x in both of those terms. So I can take out x as a common factor, right? I think this is actually like the example that we did, the very first example this year. Okay, so you can go look back at that when we talk about factorizing. And when we take out common factor, we divide each term by that common factor, right? So we're going to say x squared divided by x is x. And then minus 3x divided by x is 3. And now you need to make both parts equal to 0. Right? So you'll say the first part is x, so x is equal to 0, or the bracket is equal to 0, x minus 3. Okay, so here we already have an answer for x, and to get this minus 3 over, I'll just have to turn it into a plus 3. You can do that if you want, especially if it's such an easy one to factor. It's just like an x that you want to common factor. It might save you some time, but guys, if you don't like doing this, just do the quadratic formula. Okay, so I'm just going to make an arrow here. Or use quadratic formula. Nothing wrong with that. We've used it all the time and we have been getting correct answers, so you can use that. Okay. And this, I'm also just going to put a block around because this was separate from the question. Maybe just block that in. Okay. Okay, now guys, to that question, when we started with this equation, was it a quadratic equation? Was there any x squared? No. But somehow we ended up with an x squared. How did that happen? Okay. So we squared, okay? We used a method of squaring both sides to get rid of that square root. So do you see that it's here where the x squared came from, right? There was no x squared, it was just an x. Then we moved the 1 over, then we squared it. So we turned an equation that wasn't actually a quadratic equation into a quadratic equation, right? And we all know that when we have a quadratic equation, we get two answers. But that's not actually supposed to be getting two answers because it wasn't actually a quadratic equation. So one of these two answers might not work in the original equation, right? You see, the original equation is not the same as the one that we solved. We solved actually this quadratic equation, but we're supposed to solve this one. So now we have to go back and we have to take both of these answers that we got and we need to check whether we are actually getting an equation that works. Okay, so I want you please to write check. You don't have to write this down in a test or exam, but I always feel like if you don't write it down, you're going to forget to do it. Okay, so when you're doing these questions in class, please do write this down. First, we're going to check if x equals 0 actually works, if it makes the equation true. Okay, so for x equals 0, and I'm just going to write LHS for left-hand side. And then I'm going to put x equals 0 into the left-hand side of this equation, right? So the left-hand side was 1 plus the square root of 0 plus 1. 1 plus the square root of, now what's 0 plus 1? 1. And what's the square root of 1? 1. So this is actually 1 plus 1, which is 2. Right? So that's what we get on the left. Now, what is the right-hand side of this equation? The right-hand side is just x. But what x value are we using here? 0. Now, guys, is the left-hand side equal to the right-hand side? No. So x equals 0 does work in my quadratic equation, but it doesn't actually make the original equation true. So x equals 0 is actually not an answer to this question. Yes. How did I get it? From this line here, remember if you have two things that you're multiplying together to get an answer of 0, one of those two things have to be equal. Okay, so go back to the very first page of zeros. We did a couple of examples on it. Okay, otherwise here you can just use the quadratic formula if you want to go too long. All right, now guys, then when you notice that, when you notice that x equals 0 doesn't work, you have to go up here, you need to draw a line through that equal to show that x actually can't be equal to 0. And you need to write invalid underneath. I'm going to say it again, guys, because it might be a bit confusing because you might be thinking, why did we then get x equals 0 if it doesn't actually work? Okay, so I'm just going to say again, we turned this equation that wasn't a quadratic equation in the first place, we turned it into a quadratic equation by squaring both sides, which is why we got two answers. Okay, so 95% of the time, one of those two answers won. Okay, we just need to check for x equals 3 as well. Pretty sure it will work, but let's just do it properly. So if x is equal to 3, then the left-hand side is going to be 1 plus the square root of 3 plus 1. And what is 3 plus 1? 4. What's the square root of 4? 2. So this is 1 plus 2, which is 3. Right? So let's look at the right-hand side. Do we also get 3 for the right-hand side? What was the right-hand side of the equation? X. And what is x here? We are looking for x equals 3. Alright, so we do get an equation that works. We sub in x equals 3. The left-hand side of the equation is equal to the right-hand side. Yes. It does happen sometimes, yes. I think there are one or two questions where it does actually happen. So guys, if that happens, right, if you're testing both of them and both of them don't work, so say x equals 3 also didn't work, you would draw a line through, you'll say invalid. Then you must just tie it up at the bottom and say therefore no solution. Okay, if both of them are invalid, then there actually isn't an answer to this. All right. I'm going to give you guys a couple of weeks to practice. Yeah, okay, I'm just going to do one more example. Sorry guys, let me just check here because sorry. All right, the next example that we're going to do, number 3. It is slightly different, and I just want you guys to see what you would do in this case. So we have 3 root x equal to 2 root 3. That. All right, in this case, I do agree that the surd is not really on its own, right? There is a 3 in front of it, but leave that 3 there rather. Okay, because what's going to happen if we move that 3 over to the other side? We're going to divide by 3, right? Because here I'm multiplying by 3, there I will divide by 3. Then we're going to have a fraction, okay, which we try and avoid usually. So what we're going to do here is we are actually going to square both sides straight away. And then we must just remember to square that 3 as well. Okay, that's the only thing that's going to change here. So we need to do 3 squared and root x squared. Okay, what is 3 squared, guys? 9. And then what happens with the square root and the squared, eh? Cancel out, so it's just going to be x. Okay, so we actually left with 9x here to square both sides, which isn't too bad. Okay, that's not a bad one to work with. On this side, we're going to do the same thing. All right, what is 2 squared? 4. And what is root 3 squared? 3. Now, guys, what did I do with the 4 and the 3? They relate to each other. I need 2 times them. Good. All right, so you can just put it in brackets or you can use the times symbol if you want. So this is actually saying that 9x is equal to 12. So how can I solve for x? What can I do with this 9? Divide. So I'm going to have x is 12 over 9. Is that simplest form? No, hey, we need to always check when we're getting a fraction. Because if you're doing this in the calculator will give you the simplest fraction right from the start. But now what number can divide into 12 and 9? 3, hey? So you can do that in your head if you want. Just trying to divide by 3 there. So x is actually equal to 4 over 3. Good. 12 divided by 3 is 4 at the top. And 9 divided by 3 is 3. Okay. Now we need to check whether this is actually equal to this. Okay, so I'll just do the check on the side. Because we didn't get 2 answers, but we still get a squaring thing, all right? So by doing that, we might have gotten an answer that doesn't work. So on the left-hand side, we have 3 times root x. Now x is 4 over 3. So root 4 over 3. It's a bit difficult to do that in your head. Hey, so just type that into the calculator and tell me what you're getting. 3. Yes, okay, let me also write it quickly, just to show you. That's 3, and then you use that third symbol there. And you just do 4 over 3 like that, equals, and the calculator will simplify it for you. It is 2 root 3, and wasn't that what we had on the right? Okay, the right hand side was 2 root 3. Okay, so that answer does actually work. And if the answer works, then you just leave it like that. Okay, you don't have to write anything extra. You can just leave your answer like that. Now guys, this checking thing, you don't take marks for writing this down. So the check you can actually just do on your calculator. Right? You don't have to use time to write this down, but you do have to remember to do the check, please. Because in the previous question, if you didn't do the check, you would have lost a mark for not saying that 0 is invalid. Okay, but I almost feel like writing all of this stuff down, I mean, it's a lot of writing for just 1 mark. That makes sense. Okay, so you can do this on the calculator. I'll just write on the side. So you can just type in what's the right hand side 2, what's the left hand side, and then 2, what's the right hand side 0. Oh, it's not the same. So then you throw that in the side. Yeah, but if you're worried that you're going to forget, you can write it down. Okay. Alright guys, so let's just add to our steps here. We said isolate, square, and then solve. And the last step then is to check your answers. Let's add that there. So those are the steps that you will follow. Okay, your classwork, which will turn into homework if you don't finish now, is exercise 15. On page 18 of the textbook. Okay, 2, 7, 8, and 12. It's 4 of these. You can start working on that now.